Oh, the weather outside is frightful, but the fire is so delightful. And since we've no place to go.
You guys, I think I got it. We've been playing around. I think it's gonna snow today.
Ha! Nerd. Wait.
Fantasize about this back in Chicago. Mercy, mercy me, that mercy I go. That's me the first year that I blow. How you say broke in Spanish, me no I blow. Me drown sorrow in that Diablo.
Damn it. Hate this game.
Here comes the, y'all don't really want it like that. Yeah. Here comes the, here comes the, here comes the, y'all don't really want it like that. Yeah. Here comes the, here comes the, here comes the, y'all don't really want it like that. E-double-L, I said so. I keep big bills up in my heart on the dirty like blood, so ain't got no twist in my head, but I'm still dreadful. And I got plenty of bread, so I go to bed full of lime. Ain't it too? I woke up in a new Bugatti. I woke up in a new Bugatti.
I woke up in a new Bugatti. Tats all over my body. Getting real money.
Do the Ricky Bobby stop. Pose for the frame. Do the Ricky Bobby stop. Pose for the frame. Do the Ricky Bobby stop. Pose for the frame. And then I. Turn down for what? Turn down for what? Turn down for what? Turn down for what?
Well, hello, class. Through our quantitative data derived from the internet and from our video, we calculated the times, masses, and wheelbases of the Porsche BMW.
That's not very exciting. The real question is, what is the frictional coefficient between a tire and snow while doing a donut?
Gee, Robbie, I don't know.
Well, I can help with that. Right here we have one circle, or as we know, one perfect donut. So if we use the axis of rotation being the front axle of the car, and we know that the radius of the circle is the wheelbase of the car, we can then calculate the centripetal acceleration that the car applies while doing one donut. If we know that, and we also know the force applied by the tire, we can then, if we assume that the force of the tire is equal to the force applied by the centripetal force, and if we know that the force applied by the tire is equal to the static friction times the normal force, we can then find the static friction given that the force supplied by the tire divided by the normal force is equal to the static friction. But before we do any calculations, well, the first thing we should really find is probably the angular velocity. So to find angular velocity, we need to find. Wait, what are we going to find?
Should we sit it all written down first?
So if we have one revolution is equal to 4.68 seconds. We know that the angular velocity is equal to this. But what we really want to find to make this useful is to convert it into radians. So if we know that one revolution is equal to 2 pi radians, using our good friend dimensional analysis, we can then cancel these. And then our angular velocity is going to equal pi over 2.34 for the Porsche. And for the BMW, oh, second sign in there, just so no one gets confused. No, it's up seconds, it's pi. Radians per second. So then for the BMW, we know that one revolution is equal to 4.17 seconds. Using the same calculation as before, we can then find, we won't divide by 2 there, so we'll have 2 pi for 4.17 seconds is equal to, or radian seconds, for the BMW. Cut. Well, after we know the angular velocity, the next thing we're going to do is find the acceleration due to the centripetal acceleration. So what we're going to do first for the Porsche is, since using our equation over here, centripetal acceleration is equals the radius times the angular velocity squared, we can then find that the radius is going to be equal to the wheelbase of the Porsche, which is 2.9 meters, times the angular velocity squared. And that will equal our number for the Porsche. And then for the BMW, we'll do the same thing, except the wheelbase is a little different. The wheelbase for the BMW is 2.85 meters, times our angular velocity, once again, is 1.51, equals that of the BMW. For now, we'll call Porsche P and BMW B. So once we know the centripetal acceleration of the Porsche and the BMW, we can then find the force due to our centripetal force. All right, so if we use this formula here and we take the mass, we can then times our values right here, P and B, by the mass of each car, which over here we determined the mass of the Porsche was 2,170 kilograms, and the mass of the BMW was 2,088 kilograms. So all we have to do then is multiply the Porsche by 2,170 and multiply the mass of the BMW by 2,088. And that will give us our force, centripetal force of the Porsche, and then our centripetal force of the BMW.
We hit terminus!
Stop recording me. Mark.
All right, let's finish this thing off. So if we know that the force, the centripetal force, is equal to 11.3 kilonewtons for the Porsche, and we know the normal force of the Porsche is equal to 21.29 kilonewtons, if we divide that, we will get our frictional coefficient. And the same thing is true for the BMW. If we divide 13.57 kilonewtons by 20.48 kilonewtons, we will also get the static friction. So these values in an ideal world are going to be equal, but considering all the different variables attributed to donuts with the moving axis of rotation, depending on if it's front wheel, rear wheel drive, all-wheel drive, and depending on the amount of snowfall at the given time, the compression of the snow, They're going to be a little different, but they should be roughly equal. These values are a little different, but in general we can say most likely due to all the variables are in the range of uncertainty. But that's a wrap.
My star pupil, Pat. It's kinetic friction, you idiot.
Take me to that old familiar place. Take me to